So we can use the same concepts we use with weak acids to do calculations on weak bases. In this problem, we're asked to determine the concentration of NH3 of an NH3 solution with a pH equal to 12.20. Here the Kb is 1.8 times 10 to the minus 5. So first we need to set up the equilibrium expression for an NH3 solution. So we have NH3 plus water. It's going to be in equilibrium with NH4 plus in aqueous solution plus OH minus in aqueous solution. Here we're asked to determine our concentration of NH3. So we kind of have to set up our ice table up a little bit differently here, because we're going to know what our concentration of OH minus is in the end. So let's kind of set this thing up here. Our water does not show up in our ice table because it's a pure liquid. Its concentration is going to stay constant. We have a certain concentration M of NH3, and we're going to have 0 NH4 plus and OH minus. So our change is going to be minus X for the NH3 plus X for the NH4 plus and plus X for the OH minus. So at equilibrium, our concentrations are going to be represented by X for the NH4 plus and the OH minus, and the NH3 is going to be M minus X. So if we set up our Kb expression, we can say this is going to be the concentration of X times the concentration of X divided by the concentration of M minus X, and that's going to equal 1.8 times 10 to the minus 5. Okay, our pH is equal to 12.20, which means our pOH is going to equal 14 minus 12.20, which is equal to 1.80, which means the OH minus concentration is going to equal 0.0158, which is going to equal X in our particular expression. So we can plug the 0.0158 in for X, and that's going to be divided by our concentration M minus X, which will equal 1.8 times 10 to the minus 5. Okay, so let's try this approximation model to see what we can use here, because that would make 0.0158 squared divided by M equal to 1.8 times 10 to the minus 5. And if we go through and do the algebra here and solve for the concentration of M, we're going to get 13.95, which here is a very, very large number, so we can assume that 13.95 minus X is roughly going to equal 13.95. And our concentration here of M is going to be 14 if we round the two significant figures. So let's kind of look at how we set up this equilibrium expression, because it's a little bit different than any problem we've done before, because here we're asked to calculate the concentration of NH3 given a particular pH. So we can set up our equilibrium expression, which allows us to get the Kb. The Kb expression can be set up in terms of X, or the equilibrium concentrations. We find the hydroxide concentration to be 0.0158 based on the pH. We plug those values in, we employ an approximation, and then we can go ahead and solve for M, which is our concentration of NH3 in a solution that has a pH of 12.20. And notice that our concentration has to be pretty high here because we're at a very, very basic pH.